and talk about Heron's formula for a triangular area. My name is Amy Thompson, and this is for Math 331. So we're going to start a little bit about Heron and his formula for triangular area. It was also known as the hero's formula, and it was named after the hero of Alexandria, where this is where he also taught at a museum which included the Library of Alexandria, which is one of the largest libraries in the world. He also studied physics and pneumatic and hydraulic engineering. So with that, he made a lot of inventions. His most famous was the windwheel. It was the earliest instance of harnessing wind on land. The one I found most interesting was he made the first vending machine, and when you put a coin in it, you got a set amount of holy water. And a proof of the Heron's formula, if anybody would like to see it, is in Matrica. And here is Heron's formula. So what it states is that you can calculate the area of a triangle if you know the lengths of all three sides. So a side, side, side triangle. The normal formula that we would use to find area is half base times height. Well, we don't have the height in every triangle that we come across. So with Heron's formula, first we find the semi-perimeter. That's what that S there stands for. So S equals A plus B plus C divided by 2. And then the area is the square root of S, the semi-perimeter, times S minus A times S minus B times S minus C. So once you have S, A, B, and C, it's pretty much plugging in the numbers and doing the algebra to get the answer. So let's go ahead and do an example. So here is Heron's formula in the corner, since we're just getting used to it. And here's a triangle. So we have A equals 17, B equals 25, and C equals 26. And so here is the semi-perimeter formula. So we'll go ahead and do 25 plus 17 plus 26 divided by 2. And that's 68 over 2, which equals 34. So our semi-perimeter is 34. So now that we know that, we can go ahead and plug our numbers in to the area formula. So I've done that here. So it's the square root of 34 times 34 minus 17 times 34 minus 25 times 34 minus 26. So once we do the subtraction, we get the square root of 34 times 17 times 9 times 8. Then we go ahead and do the multiplication, and we get the square root of 41,616. Now, at this point, I would most likely pull out my calculator because that's a very big number to get the square root of. So we go ahead and find the square root of that, and that is 204. So using Heron's formula, we prove that that triangle, blue triangle in the corner, that the area of that triangle with those sides is 204. All right, so from here, what I'd like to do is, I'm just trying to pull it up, is go ahead and do some GeoGebra. And I'm just pulling out the window here. Okay, so what we're going to do first is we are going to make a triangle. I'm just going to draw any old triangle because this lovely platform will give us all the information that we need. So I put point A, point B. Where do we want to put point C? Let's put it way over there. And then we need to connect that back to A. So now we have a triangle. So let's go over here, and we're going to go here. And, oh, there we go. We needed algebra, not cast. So let's just close this area. We don't need that. So you can see it gives us the points of the triangle, and then it gives us all our line segments. So what I'm going to do, I just like to label these. So you can see this is side A, side B, side C, and we already have all that information. So let's go ahead and input Heron's formula. So S would equal A plus B plus C. Let's put a parenthesis on there. divided by 2. Not 12, 2. There we go. Just making sure everybody's paying attention. And that comes out to 9.98. So now we have the semi-perimeter. So from here, we can go ahead and put in the other formula. So let's go ahead and just write area equals. And we know it is the square root of S times S minus A and S minus B times S minus C. And let's see what happens. We hit enter, and we go ahead and we get the area of the triangle with using Heron's formula. Now, if you notice up here, when we plugged in when we made the triangle, it automatically gave us the area of triangle 1. Okay? But I just wanted to show that we can also do it with Heron's formula, and we can match the answer that the computer gives us. So I hope you enjoyed and understood Heron's formula. And next time you go to a vending machine, just think about, they used to give out holy water at vending machines. So have a great night.